Hello, everybody. How are you tonight? Welcome to Theory of Flight. So good to see you all. Give me a little comment in the chat or a thumbs up on the screen if you're happy to be here. Oh, I got one thumbs up. There we go. Very nice. More people still joining us tonight. Good to see you all. All right, my cat is intent on joining the Theory of Flight class. And
Sorry, I muted you, ma'am.
oops. That's okay. Did I get cut off mid-sentence? Okay. I think they heard me saying to like say hi and give me thumbs up, so that's good. How's you guys' week going so far? Anything interesting going on? Nothing new going on. All right. Well, listen, we have a really cool class for you guys tonight. And one of the reasons that I think it's so cool is that it ties together a whole bunch of the things that you have already been studying. So it's in the Theory of Flight category. It's Theory of Flight class number 5, Flight Instruments. But if you don't have a little bit of an idea about meteorology or some of the other subjects that you guys have been studying, for example, navigation, then this will make less sense to you. So I really like this class for that reason. We've just got one more person in the waiting room. There we go. Is anybody new to ground school tonight for the first time? I know I had 3 people join the course overall this week.
I am, ma'am.
Sergeant Tristan Craig Brown is one of them. Which unit are you from, Flight
75, ma'am.
Welcome. So happy to have you here. You'll still have a good time in this class. You'll
Yes.
still understand stuff, even if
Yeah.
you haven't done the other ones.
I mean, I've had the classes, from the mandatory level stuff, but I haven't done ground school before, so
Great.
I have like basic understanding.
Sure.
And I know science stuff.
Sergeant Slade from 598. So we've had 2 cadets just join us this week from 598. Welcome, Sergeant Slade. Happy to have you with us. So I think everybody looks like they've got their right names and stuff there. My name's Captain Eileen Carter. I'm the coordinator for the ground school. I'm teaching you as a substitute tonight. I don't know if that makes you lucky or unlucky, but certainly one thing that makes you lucky is I have 2 warrant officer second classes here to make sure that any of the mistakes I make are corrected. Warrant Officer Devinder Sarai and Warrant Officer Andreas Chamanakis are here to add their perspective as pilots themselves to the class and a little bit of extra entertainment too. So they will keep an eye on the chat and also be leading a bunch of the class. So that's great. A couple of questions coming up in the chat. Adrian LaRue wants to know if we're doing anything for Remembrance Day. Well, it's funny you should ask. The password has at least a little bit to do with Remembrance Day. And I think it wouldn't be a bad idea if towards the end of the class, maybe we just have like a moment of silence in honor of Remembrance Day happening tomorrow. So remind me of that as we get towards the end. If there's any other ideas, you can let me know, okay? All right, so flight instruments, what are those all about? Well, we've got a couple of main teaching points for you guys tonight. Let me see if I can make that a bit bigger. Can you guys all see the screen really well? Let me know if there's any problems. So our main teaching points tonight, we're going to talk about 2 main categories plus the others of instruments. We'll talk about pedostatic or pressure instruments. We'll talk about gyroscopic, which are vacuum powered instruments. They could be electrical, but either way, and other instruments. So that's the goal for tonight and our 3 main categories. So I think that the warrant officers are going to talk to you first a little bit about the 3 main types of pressure instruments that we deal with. We see these both in powered aircraft, like the one you see in this slide here, and in gliders, which some of you guys will hopefully learn how to fly next summer. Go ahead, you guys.
Awesome. Thank you for the introduction, ma'am. So I myself am a glider pilot from 2 summers ago, also from 706 in the Ottawa region. So great to see so many of you here taking this ground school. Just to start off now with the pedostatic instruments, as Captain Carter mentioned, there are 3 pressure instruments, and they are the altimeter, the vertical speed indicator, and the airspeed indicator. Together, they use the pressure system that is comprised of 2 pressure sources the static pressure source, which is the pressure surrounding an aircraft. So like right now, say you're in a room, the ambient pressure around you could be similar to what you would see as a static pressure. And then we have the pitot pressure, which is created by the forward motion of the aircraft. So it's like if you put your hand or anything out of the window of a moving car, you know that the air is hitting it at a higher like rate, and there's more air against your hand, so that'll kind of like push it back or push it up or wherever. So those are the two main pressure sources, and they help. Well, they pretty much comprise how the other three instruments above work.
All right. And so here is a little bit of a look at an instrument panel in a Cessna 172. So you can probably make out there's an instrument. Can you see my mouse on the screen? Are you guys able to see that as it moves? Yeah, Sergeant Sutton, or sorry, yeah, Sergeant Sutton's nodding. Got an altimeter here, a vertical speed indicator here, and the airspeed indicator. It's a bit hard to see over here, but don't worry, we have some more pictures for you. There you go. So we've labeled them here for you, and we are going to talk about the other three that are currently unlabeled. We've got an airspeed indicator at the top left, altimeter at the top right, and a vertical speed indicator, VSI, at the bottom right. Pilots traditionally refer to this as a six-pack. These are the important instruments to be referring to throughout your flight. So do you guys want to give a little bit of an explanation about the pitot and static ports?
For sure. So the pitot tube is what collects the pitot pressure that we discussed earlier, pressure created by the forward movement of the aircraft. So it's going to be facing directly into the direction of the aircraft. But does anyone know, you can type it in the chat, like why it's on the wing? Like why isn't it like right beside the fuselage, or why isn't it like right behind the propeller?
Because that's right where the wing is before it gets interrupted. Because in the back, the wind would have, or the air that's coming would have already been hit by the wings or the body of the aircraft.
Okay, really close. Yes, from 742, yes, it's get a false reading from the propeller, right? Because the propeller is shooting all this air back, right? So you're going to be thinking that you're at a different speed than you actually are. So that's pretty much the pitot tube. Did I miss anything, Gimenakis, on that?
I don't think so. You pretty much covered the main points. If there's one takeaway, is that it would be that the pitot tube gets the air pressure as a result from motion. So depending on the different speeds or the different motions the aircraft is going through, that pressure will change.
Great. And so here's a look. There's two pictures here. This is sort of the nose of the aircraft. You can see there's the dashboard, the dash, the instrument panel, and then the static port. Oh, I think it's like behind this label, actually. There it is. The static port is that little circle right there. And then here's a close-up of that.
Yeah, so that's usually like most times it's perpendicular, so 90 degrees to the relative airflow. So that's only capturing like the ambient kind of pressure and not like the pressure created by the forward movement of the aircraft. Great, and then together, both of these, the pitot tube and the static port combine to create the pitot-static system, which is in this diagram right here. So when you have the pitot tube, it takes pressure, and the static port, it takes the static pressure. With these two together, they provide like the basis of the functionality for the three instruments that we discussed. It's important also to note that the only one that's using both the static and pitot pressure, it's the airspeed indicator. So that's super important, definitely really key, especially for like studying and stuff. Airspeed indicator is the only one that uses both of these sources. And just to give a brief explanation of why, it's because when you're calculating speed, you need to know like your movement going forward, because that's what speed is, right? Like your movement going forward. Whereas with the other ones, the vertical speed indicator and the altimeter, they only use the static port. There's also two other things here that I haven't touched on yet. The pitot heater switch, so that can prevent ice buildup in the pitot tube, which we'll probably discuss later in more errors, but that'll just keep your air consistent and prevent any blockages, which could lead to other problems. And the second one in the bottom right is the alternate static source. So that's in case your static port is blocked, you can use another source that will serve in the same vein. Mhm. And fun fact, in most airplanes, you can actually break the glass with the BSI to act as an alternate static source, just for you, those of you who are curious.
Sergeant Billet had their hand up for a question, and then now it's gone down. Do you still have a question? I guess not. Let us know. Put your hand back up if you do have a question. And LAC Zaidan in the chat is wondering, what if your pressure chamber is all jammed up?
Okay, I'll answer that one, and then I see Sergeant Bill also raised their hand again. So yeah, so like if it's jammed up, most likely it's by ice. We also take special precautions to make sure that like nothing gets on it in the ground. So like say like insects or like, I don't know, like squirrels or whatever like kind of thing that can get in grass, So we put a pitot tube cover on whenever we're not using the aircraft, whenever it's on the ground, so that nothing gets in, no rainwater or anything of the sort. And there's also the pitot heater that I mentioned before, so that the air doesn't condense into water and then ice and block the system. Okay.
And Sergeant Billet, you had your hand up? You can go ahead and unmute yourself and ask your question. We're not able to hear you, Sergeant Billet, so I'm not sure if you're unable to unmute yourself. Oh, there you go.
Sorry about that, Captain Carter. My internet just keeps glitching on and off. Do you guys mind slowing down a little bit? You guys lost me at like the second slide of how fast you guys are talking.
We are, in fact, just giving an overview, and then we're coming back to each of these instruments. I was just typing back to Cadet Muse in the chat as well. We do want to get through all of our material, but don't forget we are recording these, and the slides will be posted on the website. So you've got some alternatives if you feel like it's a bit harder to keep up or something. You've got some alternatives to go back. So hopefully that helps. Okay.
Okay, thanks.
You're welcome. Does that work for you too? I'm not sure of your rank. I'm sorry, Cadet Louise, and let me know if I'm pronouncing your name incorrectly or not. So let's talk a little bit more specifically about the altimeter then. Oh, and Sergeant Louise put their rank on there too. Thank you so much. So like Warmaster Sarai was saying, this operates on static pressure. And so it doesn't need the dynamic pressure of what we had earlier. And inside are something called aneroid capsules or wafers. I, as a cadet, always found this really hard to understand. But you know what I do understand is if I have a bottle of water and I go on a commercial flight, Air Canada, WestJet, and I sip from that water, and then at some point I put the cap on and the aircraft goes to land, what does that bottle of water look like by the time we land? Has this ever happened to anybody? What is the bottle of water that I've half drunk, or maybe it's empty? What does that look like by the time we get down on the ground? Sergeant Sutton says it's squished. A couple of you guys have your hands up. You can go ahead, say it out loud. You can unmute yourself and participate. Sergeant Defer thinks that after landing the water bottle has expanded. That's the opposite of what Sergeant Sutton thinks. What about the rest of you guys? Sergeant Billet or Cadet Abu Hamad, what do you guys think?
So the air in the half of the bottle that has air left in it gets expanded at high altitudes.
It's true.
And then once you go to lower altitude when you're landing, it'll like compress the air that's in it.
Exactly.
So it'll kind of get smushed a little bit.
Yeah. So if you took a bottle that you could seal, either empty of water or mostly empty of water, put the lid on really tight at 10,000 feet, 20,000 feet, whatever, and then the aircraft landed, even if it had a pressurized cabin, by the time you landed, the water bottle, the empty water bottle would be all squished, almost not quite, but like similar to if a car ran over it. And it's because the pressure has changed. The pressure has changed in that aircraft. And I think Cadet Pecorella is adding that Once during takeoff, a bag of chips in my bag completely expanded. Did it pop? The other thing that you guys might have in familiarity already with the aneroid capsules and the expanding and contracting of wafers and altimeter is you probably know what happens to a balloon if you let go of a balloon, like a helium balloon, and it climbs up towards the clouds. You know that at some point that balloon is going to pop. I think we know that, right? Does anybody else have any similar examples of how atmospheric pressure causes things to be squished or be expanded when they get up higher? Have any of you guys had anything? Abu Hamad, if you have your hand up for an example, let me know. Otherwise, I can't tell if you just still have your hand up or not.
When you go skydiving, for example, before you go in an airplane, your ears kind of get they get like, I guess they kind of pop or blow up if you go go flying at high altitudes, but within like 72 hours of not skydiving, going underwater.
Yes, there are some rules around there. You haven't quite got them right, but you're pretty close. So your guys' ears act a lot like the aneroid capsules that are in an altimeter. You just don't have a little needle telling you how high or how low you are. But if you've been in a pool and dived down to the bottom, you've felt the pressure against your eardrums in your ears. Or even if you haven't ever been in any kind of aircraft, if you've even just driven up over a hill, maybe like to go to a ski hill or something, maybe you felt your ears pop a little bit while that was happening, right? And so these are examples of how air pressure is changing things inside your ears. So we all do actually understand how altimeters work. Do you guys want to add some more to that there, Warrants?
I think you covered everything.
Okay.
I agree.
Well, why don't you guys follow on then with our markings of an altimeter?
For sure. Gymnakis, you want to take this one?
Yeah, let's go for it. So as we can see, the chart is pretty self-explanatory. It works in the same manner as a clock. Your shorthand, your super shorthand
Actually,
is...
mind if I interrupt you?
Oh, go for it.
Because I don't know, a lot of the people in this room, this virtual room, might not have ever read an analog clock. So give me a yes. There's a little thing you can select that says yes, near to where you like raise your hand and stuff. Give me a yes if you read a clock with hands and a no if you don't read clocks with hands. I want to know if you guys know how to read a clock with hands or not. You can put it in the chat. You go ahead and put it in the chat if you like.
As a matter of fact, in the chat, can you guys put up what altitude this is indicating?
Ooh, there you go. That's even better. So I'm getting yeses from some of you guys anyways. All right. Well, I have more faith. I was thinking that you guys might only know how to like read an Apple Watch or something like that. Okay. Sorry for interrupting. Oh, some good, interesting guesses in the chat for the altitudes too.
All right, so I'm seeing it's pretty much varied between 1,950 and 950 feet.
I think
So
there's a
far,
bit of confirmation bias as well in the chat.
I think so as well. So far, I don't think anyone has the correct answer. I'll give you as a hint. Pay close attention to the increase between hundreds of feet.
Like how many tick marks there are between each.
There we go. I think Sergeant Defer is the first one there. So this altimeter is actually indicating 940 feet at the moment. As we can see with the first big hand, that thick hand, which is coincidentally the second point, the medium hand reads thousands of feet. Just like with an analog clock, it doesn't actually mean 1 unless it's past the 1 label, which means right now we can tell that we are below 1,000 feet, but below ground level, or below 1,000, but above ground level. The long hand, the small hand, just like in a clock, or actually in this case, it would be the large hand as labeled, reads hundreds of feet. As we can see, we've got our numbers from 1 to 10 to indicate the hundreds. But then if we kind of pay attention to the increases between each number, we can actually see 5 little ticks. And 100 divided by 5 is 20, which means we know that each little tick indicates 20 feet. So in this case, the small hand is showing 940 feet because it's 2 ticks in. Lastly, the large hand, or the small hand, as indicated, reads tens of thousands of feet. And basically, when you're super high up, such as in the flight levels, or if you're flying super high up, sometimes you may not, although you'll be able to tell with your medium hand, you won't exactly remember how many thousands or tens of thousands of feet up you are. So next question coming from that, do you guys see the striped white and black thing at the bottom of the hands, we'll call them? Does anyone know what that could indicate? All right, I'll take that as a no. So to the best of my knowledge, that is the 10,000 foot indicator. And yeah, so basically what that indicates is whenever you're below 10,000 feet, that is going to be striped to let you know that you're below 10,000. And when you go above that, it either turns completely solid white or it turns completely solid gray. And then that's just like another kind of fail safe that reminds you, hey, if I'm below 10,000, there's a chance of some ground being around. So I should probably look out for that. Can anyone else notice anything else on the altimeter that we haven't really talked about, but that has to do with the knob we can see on the bottom left corner? There we go. So we've got the pressure on the right. And how exactly does the pressure have anything to do with the altimeter? Yeah, I know the knob setting is for pressure. Defer, do you want to answer? Yeah, it's the source. So, and that is how it measures the altitude, pretty much. So as we kind of introduced earlier, the altimeter is connected to only the static pressure port and not the dynamic, and it measures the pressure of the outside air. So as we talked about from before, that aneroid capsule inside the instrument case will either expand or contract with the change in pressure. And then that is what will change and turn the hands on the altimeter, which then gives us the altitude and the indication of the number. So the expansion or contraction is, we can say, mechanically linked to the indicator's needles, which is how we get our altitude. And the reason why we have the knob and the settings is so that we can adjust our altimeter setting with the with the pressure region we are currently flying in. Does that make sense to everyone, I hope?
I actually have a short video clip, a couple of slides up to show you guys about that. So that's good. I have a video right now though for you. It's an aircraft in flight that's just below 3,000 feet and it's climbing. And I want to show you that. So let me share that instead with you. It may play a little bit choppy, in which case we'll replay it again. Let me know though. It's also a little bit loud. But just be prepared if you have a headset on. Let me see. I'll turn down the volume a bit too. It is this loud in an airplane, but you're wearing a headset, so that makes it a little bit easier. All right, here you go. Oh, it's really choppy, isn't it? Did it play for you guys?
It did not.
It did not. All right, let's try it again. Yeah, it might be asking too much to have 51 people and a video. All right, I'm going to try and play it out of the PowerPoint instead, because it's also in there. And if not, I will post this video for you guys to be able to watch on your own. Does that sound fair? We won't hold up everything. Oh yeah, here you go. Can you see that now moving, the needle moving? Gotten a bit choppy now, but you can get a couple of frames out of it. Anyways, that's the altimeter climbing up. I will repost that for you guys on the website a little bit later so that you can see it for yourself. It's just a short little clip to see that altimeter in action. So the altimeter is subject to, oh, my PowerPoint is now frozen too. That's what I get for playing videos for you, hey? There we go. So the altimeter is subject to actually a number of different errors. We're talking to you about 3 specific ones because they're more important or more noteworthy. But you can imagine it has mechanical problems and things like that too. So the three we're going to talk to you about are pressure error, temperature error, and mountain effect error. And Warnester Chamanakis already spoke a little bit about how pressure is different in different locations, and that's why we have to move that window. And I'm going to show you a little bit about what that looks like, what that means. And we're able then to change the setting to match the pressure in the place that we're going. A good analogy that helped me to understand this was, we know that right now here in Ottawa, it's just coming up on 7 o'clock, but in Manitoba, it's 6 o'clock, coming up on 6 o'clock. So we know if we fly to Manitoba, we have to reset our clocks, and we've got a dial or a setting or whatever that will allow us to reset our clocks to adjust for that. And the altimeter is the same. There's an altimeter setting that's specific to each place, and that does change over time, sometimes even in just a few minutes as different areas of pressure move through. And those of you who have taken some of the meteorology classes know that. Temperature is really related, but instead of the pressure being different, the temperature has an effect. And then the mountain effect error, those of you guys who have studied a bit about Bernoulli will know about this. And basically the speeding up or the slowing down of air creates a difference in pressure, which can affect the altimeter. And I am going to come back to those. So if you're worried about it going a bit fast, we are going to come back with diagrams to each of these, assuming that the PowerPoint will cooperate. We might need to restart that. All right, so this is the first one. This is pressure error. And so you can see that there's an aircraft here, and its little dial is showing 5,000 feet indicated. And the pressure setting is changing. So the pressure is different. It's flying into an area of high pressure, or of low pressure, pardon me. And so the dial on the instrument shows the same as it's flown inland. However, it's got an error because the pressure is actually different here. And so instead of actually being 5,000 feet, it's now at 4,000 feet. So when you fly from an area of high pressure into an area of lower pressure without readjusting your altimeter, without changing your clock or changing your watch, the equivalent, then you will have an error. And in this case, when flying from high to lower, then you'll end up lower than your dial actually says. So how can this possibly work? Let me turn away my messages. Well, you guys are probably going to look at this and go, what kind of craziness is this? You will look at this eventually as pilots, but it's called a graphic area forecast, a GFA. And I know that those are not the same order that the letters go in, but that is what it's called. And this covers much of Ontario. I'm going to show you a little bit closer in a second what that looks like. And it's a meteorological forecast that's available to pilots. I've overlaid the same thing with a Google map so that you can see the green arrows pointing towards us in Ottawa. That's Ottawa International and Gatineau Airport, and then you can see the lakes and everything there. So that's the same thing as this. And here, I've circled in purple, so there's Ottawa, there's us in there, and this is about 6 hours old, but I've circled some numbers, and this is the pressure that you're seeing. This is these are lines that join areas of equal pressure. Do you remember what those are called from your meteorology class? Lines that join areas of equal pressure? Isobars. And Sergeant Falsetto, or Flight Sergeant Falsetto did raise their hand, and then everybody typed it in, but yes, isobars. So this image is showing isobars. So I'm going to go back to the original one. You can make them out now where I had them circled, and you can see that pressure then is decreasing as we move north from Ottawa. And so if we were to get in an airplane and fly a couple hours north, our pressure would have really changed. And so if we don't reset our altimeter will have an error. Do you want to add to that, Warnester Sarai or Warnester Chamanakis?
I think you have a really good example a few slides up as well to show that like pressure can change overnight, right? So when you come to your aircraft in the morning, or if you are planning to go on glider, when you get to the gliders in the morning, sometimes it can be reading even below ground. So that's something to watch for too.
I do. Shall we try playing this video and see how choppy it is? This is, so I'm a flight instructor at the local flying club, and I was the first person to fly this airplane one morning. And when I got to that airplane, this is what the altimeter said. Now, that airplane, we're not at sea level here in Ottawa. If the ocean was here, it would in fact be about 200 feet below us. So that because of the way that the ground rises, coming away from the ocean in general, our ground level is 200 feet above the ocean. So according to this altimeter, I'm almost 300 feet underground, which is truly false. What's actually happened is an area of high pressure has moved over the area of Ottawa overnight and has told this altimeter that the pressure is higher. And therefore the altimeter says, well, I have to go lower then. I must be underground. So it's a really great example of an altimeter error. And then I'm going to use the knob on this left-hand side here to change this window to the correct altimeter setting. And I know at Rockcliffe Airport that the ground level is 188 feet. So that's what I'm going to do here. Let's see if the video will play. Cross your fingers. Well, that was a bit choppy. We'll do it one more time. That was much better. Did you guys all get a chance that I will repost it for you as well? Did you get a chance to see that? Did that make sense? I adjusted the subscale so that the altimeter error was removed. The pressure error was removed. Anything to add to that one, Mr. Chemanakis?
Nope, I think we're good.
Cool. I'm going to back up one slide here. So in a similar way to how pressure can change over distance, and you can then get an altimeter error, temperature can change over distance. And when temperature gets colder, it also makes the air more dense. And as a result, you think that you're lower. So if you were to fly as this aircraft did, when their altimeter was reading 5,000 feet in 30 degrees Celsius, pardon me, if it flew into a colder area, the same way it can be a different temperature in Montreal than it is in Ottawa, maybe not 15 degrees different, but a couple degrees different. And obviously some aircraft fly a lot farther. They might end up in Vancouver a few hours later, might have a very different temperature. Flying into 15 degrees or 0 degrees will create a big altitude difference, a big altimeter error if it's not corrected for. And typically we correct for this just by changing the subscale on the altimeter, but there are additionally calculations that we can do. It's not required in this class, just interesting for you to know that we can calculate the true altitude using information about the temperature and the pressure. So that's something you will do in a couple of years when you're on your course to get your private pilot's license. You guys want to add to that?
Sure. I'm just wondering, who knows what the standard ICAO temperature is at sea level?
Way to drag meteorology into the conversation some more. That's good.
Yes, exactly. 15 degrees Celsius. So the thing is that seldom is the actual atmospheric conditions like actually reflective of this. So for example, like right now here in Ottawa, it's like just below 20 degrees, whereas some days you could have like minus 20 or something, right? So altimeters are calibrated for the 15 degrees Celsius at sea level, whereas in these other examples here, where it's showing 30 degrees Celsius and 0 degrees Celsius, those are both not standard atmospheres. So that's why this error occurs.
Great. Is it the same way to find the altitude in a helicopter? LAC Zaidan, yes, the instruments between helicopters and aircraft are substantially the same. Some helicopters have or need some specialized instrumentation, but when it comes to things like altitude and airspeed and the other things that we're talking about here, they are more or less identical. Same thing between like other types of aircraft too. Good questions. How are you guys all doing? Are you enjoying this? Is it making sense? Is the pace good? Let me know. Got a thumbs up from Sergeant Yan. Thank you. A couple of you guys too. Don't be afraid to tell us, like some of the people were speaking up earlier, so it's good. All right, Holloway says somewhat. Let us know what we can do to do better. It's confusing stuff, to be fair, especially if it's the first time that you're hearing it. And that's why lots of people take ground school several times. I know for me, I had to take it probably 3 or 4 times before I felt like I had a somewhat reasonable grasp of it. And I have been aviating now for like 25 years, and I still need to review this stuff, especially before I teach it to you guys. So don't feel bad if you're feeling a little bit lost or a little bit uncertain. So the last of the 3 errors that we said we wanted to talk to you guys about is a mountain effect or a mountain error. Earlier in Theory of Flight, you learned about Bernoulli, right? Which said that if something in a system changes, something else has to change to correspond. And I think many of you guys on a hot summer's day have had a hose in your hand and put your fingers, your thumb maybe, over the end of the water hose. What happens when you do that? When you're holding a hose of water, just with like a big open end, and you put your thumb over the end of it and block part of the opening, what happens to the water? A couple of you guys raising your hand, go ahead and tell me. We get a bug spray, it shoots out, the stream gets stronger. Yeah, so you guys have all personally experimented with Bernoulli. Yeah, you guys all know what I'm talking about, right? So it gets stronger, and it gets stronger because the opening is smaller, so the water has to go through there faster. What's interesting that you probably don't realize is that at the same time, pressure also decreases. So the image you're looking at on your screen, my audio is bugging out. Is that happening for everybody or just for Corporal Weiss?
It's fine for me, so.
Okay, sorry about that, Corporal Weiss. It might be your internet. Yeah, I'm aware. We're gonna go over time. It's fine. So when you come to a mountain and air or wind goes through an opening in that mountain range, as you can see here, it's narrowed, right? So the same amount of wind of air has to force through a more narrow opening, so it goes faster and you get lower pressure. So if you were in an airplane and you were flying in an area where the winds were suddenly stronger and therefore lower pressure, would you expect your altimeter to read too high or too low?
Too high.
Too high. We got one answer there. LAC Zaidan agrees. So does Flight Corporal Vermette. Good stuff, you guys. Yeah, if the pressure was lower suddenly, your altimeter would read too high. All right. One after Sarai, do you want to take that one? Moving on to the airspeed indicator.
Go ahead.
Pardon me?
I think you had a really a better explanation for this.
Okay. So you guys are looking at the wing of a scale tiger moth in the top left picture here. And then I put an arrow there to point at this device here. So we showed you a picture of what an airspeed indicator looks like earlier. It's a dial. It looks a lot like the speedometer in a car, to be fair. But in the early days of aviation, they did not have any form of telling how fast they were going. All they had was the wind in their hair or in their face or in their goggles or whatever, or the sensation of motion. And then after that, they developed these. So what you're looking at here in the bigger picture is just a paddle, like a big flat surface like your phone, although it's a bit smaller than your phone. And the faster you go, the more that, can you see the spring hidden up in the top there where that thing goes? There's a spring in there and it bends back under the force of the wind, like that, the faster you go. It is the equivalent, like what Warrant Officer Sarai was saying at the beginning of the class, of sticking your hand out the window of your car. And I think if you did that, and somebody said, oh, we're going 50 or we're going 100, and then later they asked you the same thing, like how fast are we going now, you could probably say, just based on your experience, you've calibrated your hand out the window of your car, you could be able to say you're going 50 or 100, maybe even 30, whatever the speed was. So this is the original airspeed indicator. It's not more complicated than that. Isn't there the same instrument but not on the wing? Not really sure about your question there, LAC Zaidan. If anybody knows and wants to clarify, or if you want to add to that, let me know. but we don't have these ones anymore, if that's what you're getting at. We've got something a bit more calibrated, and it looks like this. So it reads our airspeed, not ground speed. And that's important because ground speed and airspeed aren't necessarily the same. I think we're going to have to get into more of that another time, but it's good to know that. And it will measure the difference between the static pressure, that's that little one on the side, and the pitot pressure, the one coming in that tube, to be able to tell you the difference and therefore how fast you're going. So let's take a look at the dial of an airspeed indicator. And it's got some colors on here that tell you a couple of different things. It can be calibrated either in knots or in miles per hour. And knots are just nautical miles per hour, so not that far off from miles per hour. So the red line at the top of the arc, because the needle goes around it clockwise, the red line there is the VNE, and VNE stands for the velocity never exceed. This is the fastest speed that the airplane should go. Can it go faster? But it shouldn't, is the point. It's the velocity you shouldn't exceed. We may talk more about why that is in a different class. And the other end of the scale, all the way back over here, is VNO, which I'll give you some definitions of on the next slide. LEC Zaidan, why don't you unmute yourself and tell us what your question is, because I'm not quite following you. Do you have a microphone? Can you tell us?
Can you hear me?
Yep.
Okay, when I mean that indicator, I just want to ask, isn't there the same instrument, but that indicates the speed, but inside the cockpit, inside the airplane?
The one that you're seeing on the screen there,
Oh,
let me show you. See this picture here from inside of the cockpit? That instrument here on the left-hand side that's a little bit blurry because it's a bit farther away is the same one that I'm showing you a slide of now.
Okay, thank you.
It's just in the old days, they had to put them outside because they were working on technology. They had no iPhones or anything.
Okay, thank you.
You're welcome. All right. So then you can also see that we've got a green arc. This is sort of the normal speeds that we operate in. They color code things for us pilots. You know, we're not necessarily, we have to study a lot, but we're not necessarily all that smart, really. So the green is the normal range. And then there's also, oh, it doesn't say, there's yellow caution range here. This is when it's above our normal speed, but not quite at the never exceed speed. And then there's a white arc or a range for use of flaps. My slide won't change for some reason. Anything to add to that, guys?
Excuse me.
Yes, please.
In like a usual circuit, what speed would you be going at in different parts of the of the circuit, like a glider, for example?
All right, well, I'll let one of our glider pilots answer.
Good question. So what speed do you want to be going in the circuit? So on the downwind leg of the circuit, you want to be established at your best L over D speed, so like your best glide speed for 233, like around 50 miles. And then once you get on to your base turn, so you have downwind, base, and then final, you want to establish yourself with the speed that you'll do in your downwind checklist, which is for another time, based on the winds of the day, pretty much. And then say that you have a headwind at like 10 knots, you want to take 10 extra miles per hour of airspeed so that you can actually have the same ground speed when you're landing. But we never go below the best L over D speed, the best glide speed, even if there is a slight tailwind, which is really rare, but we still don't go below that speed because then we're in danger of stalling. Good question.
Great answer.
Thank you.
So on here is a list of V speeds. I'm going to post these slides because, I mean, the three of us pilots, we could talk forever to you about flying, and I'm already at what's normally the end of class time. We're clearly going to go over, and I can't go past 7:30, obviously. So you'll forgive me for not going through all of these. For those of you who are studying to write an exam this year, the most important numbers on here are the VNE, the velocity never exceed the red line, the fastest speed that you can go, and possibly the maneuvering speed, the VA speed, this one down here, second from the bottom. The other ones are kind of vaguely interesting, but not super relevant to you as beginning in aviation just for now. You're not likely to be asked questions about those. So VNE and VA. Oh, you need a link to attendance. Do you guys have access to that, Warrants, or do I need to go get that? Let me know.
I can pull it up.
Thank you. All right, and we will give you the password too. I'm just waiting to finish my pedostatic instruments, and then I'm going to give you the password. I have it here on a sticky note. Thank you though, Sergeant Yan, I appreciate it. Okay, so the airspeed indicator also has some errors. I don't have diagrams for you for these because they're fairly straightforward. Warrants, did you guys want to go through these? Because otherwise I go through them very slow, so you guys might be a little faster than me.
Yeah, sure. I think I can cover them quickly. Pretty much, whenever you're not at at the level of the sea level, there's like a non-standard pressure because it's calibrated for the pressure of 29.92 inches of mercury. Nice. Two, we have positions. Position error. So kind of how we talked about why the pitot tube isn't right behind the propeller with slipstream. There still is some position error with the relative airflow. Lag error is just mechanical friction between the parts. Icing error is, so we talked a little bit about ice covering intake of the pressure sources, which is why we have the pitot heat. And then water error is water in the system, which we counteract by having our pitot tube cover and that on when we're not flying.
I know we went through that a bit fast, but these are not things you're likely to be asked about on your entrance exam. What we want you to take away from here is that there are sort of a variety of small things that might happen to affect the airspeed indicator, predominantly related to the pitot tube or to the temperature and pressure. And the attendance link is in the chat. Thank you, Mr. Chemanakis. Okay, we'll take a quick look at the vertical speed indicator, if my slide will change. We haven't given you the password yet. We're going to give it to you in a minute. Don't worry. I have it written down. Oh, you need it for the attendance. Okay, well, while we wait for my screen to change here, your password for today is Björling. I'm going to type it into the chat for you so you know how to spell it. And this is the last name of a fighter pilot from World War II. So I think it's really appropriate actually for today, for Remembrance Day, to have George Björling as our password. He was one of Canada's best fighter pilots for World War II, shot down 27 aircraft in a 14-day period in World War II. So George Björling. All right, for whatever reason, my slide won't change. That's no good. Oh, there we go. All right. I think because I'm hosting so many of you guys, it's just got a lot of lag. All right, so the vertical speed indicator is the third and last of our pressure instruments. It just tells us how fast we're going up or down. And if you remember that video that I showed you, which I'll repost so you can see again, it was an instrument, in this case, just below the altimeter that showed that we had a rate of climb or a rate of descent. It's got some more of those like things inside. It's got some discs inside, and it can basically compare the rate of change of static pressure. So it can tell if the pressure is getting lower or the pressure is getting higher and how fast that change is happening. And it translates that into, oh, we're climbing 100 feet per minute, or we're descending 200 feet per minute. And so that's the purpose of the vertical speed indicator. It's got markings, and it depends on what you're flying. If you're flying a nice soaring glider like Warren-Officer Sarai or Warren-Officer Chemanakis in the summer, it might be like the bottom one, showing a climb or descent in knots. And so when you find a really great thermal and you're climbing in your glider in the thermal to stay up for, what was your longest flight this summer? 4 hours, something like that?
No, it was 2 hours and 36 minutes.
Oh, pardon me, only 2 hours and 36 minutes in a glider. Then maybe you'll show that you're going up 4 or 6 knots per minute. If you're in a Cessna or another aircraft, it might be a little bit more like the top one there. And the vertical speed indicator, the VSI, is subject to errors as well, because it has to have an actual change in altitude in order to register the change. Then there's obviously lag. That is to say, you have to climb a little bit before there can be any change. So then only then can it register the fact that there has been change. And so as a result, we sort of expect it to be a few seconds behind what it is that we're doing. Oh. I think your instructor for your next class is here to check things out. Hello, Lieutenant Weinberg. I'm running a little bit behind, I'm sorry. Let me know if you can hear me. It's not my fault, it's just that my slides don't work. All right, so I'm gonna really quickly tell you about gyro and vacuum instruments. The reason it'll be pretty quick is, well, I'm almost out of time for you guys, but also it's not something that you're likely to be examined on. So I just don't want you to leave with an incomplete understanding of instruments. Originally, we said to you that we were going to talk about the 3 pitot-static instruments, the altimeter, the vertical speed indicator, and the airspeed indicator, and there was 3 other ones here. We've got the attitude indicator, sometimes called the artificial horizon, because you can see it's got a little orange plane in there. It's got the ground, it's got the sky, so it's a little bit like having an artificial horizon. We've got a heading indicator. You can see the similarities to a compass, and a turn coordinator. Fairly frustrated with my slides that I can't get to the next one. There we go. So you guys know what a gyroscope is, right? You've seen those spinny things like NASA has at trainers where you can like spin around in 3 dimensions, or maybe you've even played with a gyroscope. If not, you know what a spinning top is, perhaps. And so the idea of a gyroscope is that it will spin, and no matter what the airplane that's around it does, it will stay rigid in space. So the airplane moving can show something happening in a dial. That's what you're looking at here. They can be electric driven or vacuum pump driven. I left a really cool video of the vacuum portion of that on the website for you to take a look at a little bit later. And so that'll be interesting for you to see, I think. Interestingly too, there's recent news that at least in the United States, they've started allowing digital ones. And so vacuum instruments may become a thing in the past, but it's not really relevant to you guys right now. So the attitude indicator is this first instrument. You can see the little yellow wings of the airplane, the blue for the sky and the brown for the ground. And on this slide here, you can see what would happen if you were, say, banked to the left in a straight climb, descending to the right bank. And we'll show you what your airplane is doing relative to the horizon. This is pretty useful if you're flying in clouds, flying at night, or somehow disoriented. The heading indicator is a little bit like the compass, except for that this tells the pilot what her heading is in a different way. So the compass is usually like up higher here, and it turns a little bit awkwardly. You guys have all worked with a compass before in the field, probably. And the heading indicator is sort of flat, closer to the front view of the pilot. And so it's easier to look at. And when you turn to the right, it also turns that way too. So it's not a bit backwards. I'm not sure, Sergeant Yan. It might have an altimeter setting. I don't remember. Does anybody else have an Apple Watch that knows the answer to that? And then the last of the 3 vacuum instruments here is the turn coordinator. You can see a picture of it at the bottom left. It's got a gyro inside as well. It's oriented a bit different. And it shows yaw and roll plus coordination. So you can see in this next set over a coordinated turn, aircraft banked to the right, and there's a little ball in the bottom that's in the center. If you're not coordinated, it moves to the side. If you have ever gone around a corner in a car, sorry, cat. If you have ever gone around a corner in a car and pushed somebody to the outside corner of the car, you have acted like the little ball in the middle of these pictures here, skidding, pushing somebody to the outside. But that's a different story, and then slipping. Lastly, the other instruments we wanted to just very briefly mention to you for completeness. No need to necessarily know a whole lot. There is compass, the compass and engine instruments. You guys already know what a compass does, points to north and is required in aircraft. And then for the engine, there is something called a tachometer. Just tells you how fast specifically the crankshaft of the engine is turning over. And it's calculated in revolutions per minute, RPM. And it has like a normal operating arc, a green arc, and a red line too, where you're not supposed to go faster. And then most aircraft have additional gauges, as you can see in this picture here, for example, showing how much fuel you have, or showing, this one actually is EGT. I meant to put a picture in here showing oil temperature and oil pressure, but I put the wrong one in apparently. Warrant Officer Strai and Warrant Officer Chamanakis, anything to add? I'm down to the wire here, sorry.
I think there's just an interesting point for the Gen Zs in the call with gyroscopes. If you think about like the fidget spinner craze, a fidget spinner is a gyroscope essentially, right? So if you spin it really fast and you hold it and you try to change its direction, it'll actually resist you changing direction. And it depends which way, because which way you turn it and then which way you try to change direction. So that's like a good way to think of when you watch the videos on the site as well, just to keep that in mind if you want.
Fidget spinner. I didn't think about that. We should add that in here. That's cool. All right, guys, I know we did speed through the last of it. I did have some questions for you. I will put the slides up, like I said, and you can watch the video. If you have any issues with these, let me know. But I wanted to take the time to interact with you and to explain this stuff. So we overshot our time limit a little bit. Does anybody have any pressing questions for us? LAC Zayden has a question about the attendance. Go ahead. While you're putting that in, are you going to unmute yourself? I'll just ask you guys to complete the mid-course survey as well and let us know. Go ahead, LAC Zayden.
Okay. So I have a question regarding on the attendance, and I can't really grasp the concept of what you're supposed to do. So if many of the officers said that the attendance is just for the people that are not here. But I'm here, but am I supposed to do it?
Yes.
I don't really understand what I'm supposed to do.
So I do attendance from the people who are in the Zoom class, but it sometimes doesn't work. And so we give you guys the link and ask you to fill out that so I can compare the two to make sure I avoid errors as much as possible. As you can imagine, with 182 of you guys spread over 2 nights and asynchronous, it's a big project. So the more data points I have to try and avoid errors, the better. So if you could fill out that once per night, I would appreciate it. If you don't fill it out, it's not the end of the world, but it helps me a lot.
Okay, thank you.
Thank you. Well, listen, guys, I did put the link to the next class in the chat. I really appreciate your attention tonight. I hope you learned something. You can give me a thumbs up if you learned something, or if you didn't, give me there's no thumbs down. You're out of luck. You have to give me a thumbs up. But seriously, if you have some more questions, then please let me know. Oh, I got an in-person thumbs up from LaRue. Thank you so much. Sergeant Reddy confirms there is an altimeter in the Apple Watch. Anyhow, I had a lot of fun, you guys. I hope you did too. And like I said, you're off to your next class with, let me see. Oh, it is with Lieutenant Weinberg, who popped in there briefly. You guys have precipitation and weather formation for meteorology number 6 tonight. So thank you so much. Really appreciate you guys' attendance and all of your dedication to this, I know, challenging course. So have a good night, you guys. You're very welcome. Yes, and thank you to the warrant officers who kept me on track. I probably would have gone a half hour overtime without you guys. Yes, Bierlein was the password today. George Bierlein. Bye, guys.